Hi, this lecture we are going to explain some properties of z-transform. There are many properties of z-transform that it can help to find the z-transform for other functions and other sequence that may look complicated, and make it simple, not use every time the formula to find this transform. Let's take the first example here. Let's say that you have a sequence, and this sequence has unit step from 0 up to infinity, and on the other side we have unit step but flipped from minus infinity to 0. It's equal 1. So that's the sequence that we have now, and we wish to find the transform of this sequence. Well, we know the one on the right hand side, it's a unit step, and unit step is defined as u of n, and we know it's z transform. It's equal 1 over 1 minus z power minus 1. We proved that last lecture. And also there is a table in the handout. You can look at it and you'll find that the z transform of unit step is equal 1 over 1 minus z power minus 1. Sometimes some people like not to have z power minus 1, so you can find the equivalent by multiplying the top and the bottom by z. So you can say it's equal z over z minus 1. Both are the same expression. But what about the one to the left, this part? First, you have to find the expression for this one. Well, to make it easy, I will just use a continuous signal just to show you what is different between that and that. That's a unit step, all right? We'll call it u of t if we have the continuous one. And if you have reflection on the vertical axis of the unit step, you will have it like that. So how you represent that? When it's reflected on the vertical axis, you write it u of minus t. And if you have, instead of 1, you have negative 1, so you can express this as minus u of minus t. So that's the part if you do in the continuous. If you want to find the equivalent in discrete, something like that, so you can just have the sample, you will write minus u of minus n. So just replace t by n. So this part, you can write it like minus u of minus n. So now we have, if you add both, then you get this function. And by the way, if you wanna know the continuous version of this one, it will look like that. It will be 1 in this direction and minus 1 in this direction. They call it sine function. So we want to find z transform of this one. Well, so now we know how to write the expression for it. It's equal un minus u of minus n. So what's the z transform of this function? Okay, we know this one, as we explained before. It's equal z over z minus 1. What about that? Okay, so we need some property that explain if you reverse the sequence or you reverse the index from n to minus n, what happens? Well, actually there is a rule of the property. When you reverse, we'll say that the sequence, when you change from n to minus n, first you have to know that the original one, it gives you f of z. But if you add a negative sign to the n, all what's supposed to do, use this expression and instead of z, replace it by 1 over z. That's all. Well, how can we do that here? All right. We know that the step function, unit step function, it will go to z over z minus 1. So if you want to find u of minus n, all what you're supposed to do, you replace every z by 1 over z. So that will be 1 over z, that 1 over z minus 1. And just to simplify, multiply the top by z, the bottom by z, z times 1 over z be equal 1. And that will be equal 1 minus z. So that will be the z-transform of this sequence. If you want to continue and finish the problem, let's just write x of n is equal u of n minus u of minus n. The first one is equal z over z minus 1, and the second one, just got it now, 1 over 1 minus z. To simplify it, you can change this sign with this sign, multiplying, you have positive 1 over z minus 1. Now we have a common denominator, so you have z minus 1, and then just you add the top will be z plus 1, and we are done with the problem. So that's how you find this function. Okay, now let's go to another example, another property. The other one, shifting property. Let's say that I'd like to sketch the continuous and then we'll make the discrete. Let's say that if you have a step function shift like that at 5, how you write this one? You say u t minus 5. How you do it in discrete? Come at 5 and just start to write your symbol. Height is 1, and that's n, and that's x of n. So the function now x of n, or the sequence, is equal to u of n minus 5. Well, how can you find the the z-transform of this one? Well, the property said that if you have a sequence f of n, its z-transform is equal f of z. If you want to shift it by certain number c, all what you're supposed to do, you multiply f of z by z to the power of minus this number c. According to this property, now your c is equal 5. Remember, it's n minus c, not plus, okay? n minus 5 is the same, so c is equal 5. If you apply this rule, you'll say that u of n, without any shifting, you know it's equal z over z minus 1. If you are going to shift it by 5 units, so you just write z over z minus 1 and multiply it by z to the minus 5. And of course you can simplify it. It will be equal z minus 4 divided by z minus 1. Even you can simplify it more. You can say 1 over z bar 4 times z minus 1. And we are done with this problem and this property. Simple, right? It just make life easy. Let's take another one. What about if we are multiplying a function by number power n, exponent, like find z-transform of 0.5 power n un. Okay. The property said that if you have a sequence xn, z-transform is equal x capital of z. If you are going to multiply by a constant a to the power of n, all what you're supposed to do, get this z-transform and divide every z by the constant a. Well, let's do our example now. Un, we know it's z-transform equal to z over z minus 1. If you want to multiply it by 0.5 n, un, you are going to divide every z by 0.5. So z by 0.5, z by 0.5 minus 1. And simplified, multiply it by 0.5 up and down. So you'll have z over z minus 0.5. Actually, it's simple. Very similar to the step z over z minus 1, but this one z over z minus a, the constant. And it's very useful formula. You're going to use it a lot. All right. Let's take one more example. Find z-transform of ramp, unit ramp. For unit ramp. I'll sketch unit ramp that starts from 0. It's the time, and r of t, that's equal t, slope 1. If you do the discrete version, you'll have n, and you have r of n. You have 0 and start, increase linearly. Okay, so r of n, it's equal n, and since it starts from 0, you have to multiply by unit step u of n. So we need property that tell us what happened when you multiply a sequence by n. Yes, there is an important property of z-transform called the differentiation property. It says that if you have a sequence f of n, the corresponding z-transform is equal f of z. If you multiply this one by n, all what you're supposed to do, you find the first differentiation of f of z and multiply it by minus z. Let me just continue and tell you, what about if it's multiplied by n square? Well, you will do the process again. You are going to differentiate again and multiply it by another minus z. So you can continue and do it n bar 3, n bar 4. So every time you differentiate, multiply by minus z. Just let's, to make it simple, I will just solve this problem that we have it in our hand now. All right. Well, it's un, the original one. So write un, the unit step, give us z over z minus 1. And if you multiply it by n, which is the ramp, you are going to differentiate. So, and multiply by minus z. So you want to differentiate with respect to z, z over z minus 1. So I'll say z equal minus z. The differentiation, it's a fraction, rational form, so you square the bottom, and then you differentiate, z will be equal to 1 multiplied by z minus 1 minus z multiplied by the differentiation of this one, which is equal to 1. So z equal minus z, z minus 1 square. You have z minus 1 minus z. That will cancel. It's left minus 1 minus z will be equal z. So the final result will be equal z over z minus 1 square. That will be the ramp. I will stop here. There is another important property for z-transformation, which is called convolution, but it's a little bit involved, so I will keep it for another video. Thank you for your attention.